Dear students, in this video I will explain all the possible solutions of the fourth order homogeneous linear ordinary differential equation with the constant coefficients. Based on the roots of its characteristic equation, we got 9 kinds of solutions here. That are the first one, when the roots are real and distinct, that means the roots are m1, m2, m3, m4 and all are distinct real numbers. That case, the solution y is c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x plus c4 e raised to m4x. Case 2, when the roots are real and equal, that means we got 4 roots, let it be m1, m2, m3, m4 and such that m1, m2, m3, m4 are equal. We can call this by a small letter m. Then in that case, the solution of this fourth order homogeneous linear ODE is y equal to c1 plus c2x plus c3x square plus c4x cube e raised to mx. And in case 3, the roots of this fourth order homogeneous linear ODE are m1, m2, m3, m4 all are reals in which m1 and m2 are same. That case, we know the solution y is c1 plus c2x e raised to m1x plus c3 e raised to m3x plus c4 e raised to m4x, since m3 and m4 are different and m1 and m2 are equal. Fourth case, when the roots are m1, m2, m3, m4 and all are reals in which m1, m2, m3 are equal and m4 is a different one. So that's case, we know the solution y is c1 plus c2x plus c3x square e raised to m1x, this m1, m2, m3 are equal, plus c4 e raised to m4x because m4 are different. And on the fifth case, the roots are m1, m2, m3, m4 in which m1 is equal to m2 and which is real numbers, and m3 and m4 are complex like alpha plus I beta and alpha minus I beta. We know that case the solution y is c1 plus e2x e raised to m1x for repeat m1 and m2 and e raised to alpha of x into c3 cos beta x plus c4 sin beta x for 2 complex roots. And this is the solutions of that case. And on sixth case, when the roots are m1, m2, m3, m4 such that m1 and m2 are real numbers, different real numbers, m3 and m4 are complex conjugates like alpha plus I beta and alpha minus I beta. That case, we got the solution y is c1 e raised to m1x plus c2 e raised to m2x because m1 and m2 are different plus e raised to alpha of x into c1 cos beta x plus c2 c4 sin beta x for complex roots, remaining complex roots like alpha plus I beta and alpha minus I beta. And in the seventh case, the roots are m1, m2, m3, m4 all are complex in which m1 and m2 are one of complex pairs alpha plus or minus I beta and m3 and m4 are different complex pairs gamma plus I delta and gamma minus I delta. So that's case, we have the solution y is e raised to alpha of x into c1 cos beta x plus c2 sin beta x for alpha plus or minus I beta and e raised to gamma of x into c3 cos delta x plus c4 sin delta x for the different complex pairs gamma plus I delta and gamma minus I delta. And to the eighth case, the roots are m1, m2, m3, m4 such that m1, m2 are complex pairs alpha plus or minus I beta, m3 and m4 must be same as m1 and m2. That's case, the solution y is e raised to alpha of x into c1 plus c2x cos beta x plus c3 plus c4x sin beta x, since alpha and beta are repeated 2 times. And to the last case, when the roots are m1, m2, m3, m4 such that all are real numbers in which m1 and m2 are equal real numbers and m3 and m4 are another equal real numbers. So that's case we got the solution y is c1 plus c2x e raised to m1x plus c3 plus c4x e raised to m3x. Problems. First question. Find the general solutions of d raised to 4 plus 3d square minus 4 of y is 0. Solution. We know the auxiliary equations of the given ordinary differential equation is m raised to 4 plus 3 m square minus 4 equal to 0. And we know this is a quadratic equation m square, and take m square as k, then we got there is a quadratic equation k raised square plus 3k minus 4, and solving this quadratic equation by using calculator we got k is minus 4 and 1. We know k is equal to m square, that's why m square is minus 4, m square is 1, and hence we get 4 roots of the given ODE is m is plus or minus 2i and m is plus 1 and m is minus 1. And this is the case of fourth order ODE having 4 roots in which 2 are different real roots and 2 are complex roots, and according to general theoretical section, and this is the solutions of that is c1 e raised to x plus c2 e raised to minus x plus c3 cos 2x plus c4 sin 2x. And in problem number 2, find the general solutions of y4 dash plus 2y double dash plus y is 0. The solution. The characteristic equation is here we have m raised to 4 plus 2m square plus 1, and we know this is m square plus 1 the whole square, that's why we get m square is minus 1 and m is plus or minus I plus or minus I, that is it is a case having m1 alpha plus I beta, m2 alpha minus I beta, m3 once again alpha plus I beta, and m4 is alpha minus I beta. Here alpha is 0 and beta is 1. Therefore from the theory we get the general solutions of this particular ODE y of x is c1 plus c2x cos x plus c3 plus c4x sin x. Thank you.